Hi, my name is Alex, and I want to introduce you today one interesting feature in Incremental. In Apache Maven, which is like incremental build, this feature was long awaited by many of my colleagues, so I hope it will be interesting to you too. So let's start and let's see what is it. First, idea of incremental build, what is it? In a very simple form, that means that you do not redo work which has been already done. If you have built something, you want to reuse that and save your time by doing less work. So, and in that definition, if you change something in your project, you expect that build and actual build steps will run only over the changed part of a project. So, for example, if you change like only small part of your project, like one project, one module, and the build tool will rebuild that module and dependencies of that module, and that's it. And also, you probably expect that you have some ways to share results, because if you want to cache something, it's very important to be able to share results. And here you want to share it locally, because like local cache is very performance efficient, but also you want to share it remotely, because in that way you can share results between different workstations, continuous integration agents, and other like tools which might be interesting in the results. So, and again, like Maven, unfortunately, never supported that to full extent. There were a few plugins and were very limited support for that in Maven, and that didn't change big picture. So in most of cases, if you do build 2 times, likely you will have some very minimal difference. So it actually never like was the same results as you probably can observe in our well-known Java build tool Apache Gradle, in a Gradle. So basically in Gradle, if you rerun your build over, like say, existing working directory, it will complete amazingly fast. And we will take today Gradle as a kind of baseline for comparison of incremental builds implementation, and you will see that Maven actually has something to surprise you. So let's move forward. Some background behind this feature. Initially, it was developed in Deutsche Bank and donated to Apache Software Foundation. Thanks a lot for Deutsche Bank for allowing that, and I'm happy to share this feature with you today because of that donation. So some history of this work. Initially, it was developed as a tactical solution for a very huge project. It's like about 700 modules, I think a lot of source code, and basically build hit scalability issues. It took longer than everyone could actually like tolerate. So it became a bottleneck. So the project is very active. There is dozens of teams who work actively on that project. And if you're doing like a lot of small changes, a lot of commits in the project daily, you actually have a very high load on CI. And CI performance becomes a bottleneck for your process, because if you cannot verify build, if you cannot like push your change forward fast, you actually kind of pile backlog of changes, and they start conflicting, and it becomes like more and more difficult to cope with new incoming changes. So one of the key motivations for delivering that tool, for implementing that tool, was a continuous integration efficiency and overall efficiency of a release process. So looking forward and like sharing like maybe some results, but this tool actually addressed that very well, and over a year it proved efficiency and stability, and it's without any discounts, is a kind of production ready and very stable, so you can actually take and use it and rely on it. So now it's demo time. It's not just words, so we will see by our own eyes how it works. So I have a project. This project is called Performance Comparisons, and it was prepared actually by Gradle team. Gradle team created this project with purpose of comparing like performance times of Maven and Gradle, basically, I think. And because Gradle supports incremental builds and Maven does not, basically, result was predictable, right? Gradle was like beating and showing much better numbers in many situations. So so let's take a closer look at this project. So this project consists, and I will take a full screen probably. This project consists of about 50,000 source code files and 50,000 test classes. So it overall like 100,000 source code files, and there are 100 projects in a directory large multi-projects. So, and looking at the build graph of a dependency graph of this project, you can see it kind of looks very real. So if you ever looked at real life projects, they look very similar. You usually have some foundation modules, and there are some dependencies at top of that, and there are more layers which depends on the second layer. So a very realistic model, very good, and it's kind of looks as a good project for actual performance comparisons. So now about the Maven. So to set up a build with Maven, with incremental Maven, I actually took a package created from this feature branch. It's a regular Apache Maven binary zip. So I just unpacked it as usual. It's here. So, and the only thing which is noticeable here is cache config. But cache config is a separate subject. I hope I will be able. I will return to this subject later. But if you are interested, there is a cache documentation in feature branch. You probably can contact me and on YouTube, and I will try to share like how to bootstrap your project if you're interested. So basically two things here. You need a binary distribution of Apache Maven created from feature branch, and you need a cache config to actually configure cache for your project. You do not need any modifications in your project beside that, except that maybe you will find some discrepancies in POM files which prevent cache from being like efficient. Okay, so this is a project setup. I probably explained project and few words about environment as well. So I will use 2G's memory allocation. I will use parallelism of 6. I will use quiet mode because it turns out that performance of console output affects performance in many cases. So it skews numbers, and need to disable that. I will use Oracle hotspot JDK, Java 11, and I have a like i5 6 cores, 16 gigs SSD, kind of medium workstation, but sufficient to demonstrate this feature. So okay, first of all, about the build. If I will take this project as is, and I will go and will try to build it without any optimization, cache, anything, it will take about 5 minutes, something like 5 minutes, 30 seconds. So that's a baseline. That's a cost of clean build. Now you can see result of a previous run here. It took 22 seconds. So that how long it took to build with incremental Maven. Why? Because previously I have pre-built that project and warmed up cache. So basically, if you have cache which is ready and called which could be reused on your workstation, cost of build goes from 5 minutes 30 seconds to 22 seconds. Like it's like 16 times a win. Very impressive. So let's see by our own eyes that it actually works. In this case, I think 5 file system might be not warmed up, so it could take like few seconds longer, but let's see. So here you can see non-standard output. You can see like word cache, and if your eyes are fast enough, you can see something like hash sums and the output. And in overall, you can see it goes amazingly fast. So basically, we're already almost done. And let's see the final number. In this case, it's 23 seconds, but close enough, right? So 23 seconds is a actual build time with cache in Incremental Maven. Now let's take Gradle in similar situation. And in my previous run, it took 54 seconds. So basically, Maven was 3 times faster. But this case maybe not so interesting, right? Like I just have restored a project from cache without any changes. In real life, you will likely have changes which you need to validate. So, and that's a situation. That's the next case, which I call Subtree. So, in Subtree case, you basically have a change in one of the intermediate modules, and in that case, as I said, you expect likely that incremental build tool will rebuild changed model and also dependencies of that module, because like something could change and impact and introduce a regression. So in this particular scenario, I change module 16, which is in the middle of a graph, and then validates roughly about 25% of a project. So, and if I do that, so for example, I do simple change, I rename property, and that actually change the source code file and one test, just 2 files. And if I do that, as I said, that invalidates roughly about 25% of a project. And the build time in that case with Incremental Maven will be 1 minute 4 seconds. It's here. And with Gradle, 1 minute 3 seconds. So basically, very close time, and that kind of proves that like both tools are very efficient in scenarios like that. So now, but that's not all. And one more interesting scenario I want to demonstrate is a situation when you actually have, for example, a huge inputs and outputs in your build process. For example, you write a very extensive log files with debug output, probably because you want to capture some diagnostic information to investigate test failures or something like that. Nothing exotic. I think it's a kind of common sense and like a usual situation. So basically, in that case, Gradle build surprisingly took 5 minutes, almost the same time as a build without cache. And going forward, you actually could discover that a build with cache in Gradle could actually take more time. It could be slower when built without cache at all. So that's like specifics of Gradle implementation, and it could be perfectly explained. That's like a kind of implications of Gradle cache design. So basically that's it. What the highlights here is that it's possible to take Incremental Maven with Maven Works, and it shows performance like in many aspects, maybe even better than Gradle. And honestly, this is exactly what you have to expect, especially in continuous integration situations. So I think that's like fair expectation that Maven incremental build will behave faster, will work faster, will provide more efficient results. If you use AWS and I don't know, like maybe some cloud provider and pay per CPU like time, I think it will just literally save you money. Okay, now let's take a summarized view of test results. So, okay, I need to remind, I use local cache in all these scenarios. That means that like I warmed up, I pre-built the project on my local workstation. There is no remote calls to restore the cache, and that's a kind of performance-friendly situation. So, okay, if I do not do anything, if I just use cache build as is, so I just go and build without caches, without everything, 5 minutes, 40 seconds in both Gradle and Maven, very close results. So if Gradle is up to date, if working directory is up to date, it completes amazingly fast, like 3 seconds and half, like 3.5. So now, if a working directory is not up to date, if it's clean, when Gradle restores everything from cache, and that's still possible, but takes 38 seconds, much faster when regular build, so give some benefits. And that situation when you have actually very extensive outputs from your tasks, like in my case, I emulated that with std_out. In that case, build produces huge JUnit reports with std_out captured exactly as you want in tests. So, and in that case, you can like play with size of std_outs, and it's not difficult to achieve situation when Gradle build actually takes longer with cache than just the usual regular clean build without any cache at all. So, and now let's take a look at the right column, and here is the main number, 15 seconds. Incremental Maven in all these situations behaves like amazingly fast. It takes 15 seconds to complete in all these cases. So that's just great. Just want to notice what in real life your likely will be somewhere between this number and probably this number, because in real life your outputs, your task will have outputs, and this project, for example, is kind of simple one. It's just a Java class and Java tests, and that's it. In real life, you likely will have more tasks with more outputs, and it will be much more overhead for Gradle, likely. So, but that's a situation when you actually do not have any changes in project at all. You're just trying to reuse existing build, and that's like kind of not so interesting situation. More interesting situation when you actually try to rebuild a kind of partially changed tree. And returning to that situation, which was described earlier, for example, if you invalidate 25% of your project by your change, and let's take a look at two situations. First of all, you can be in this zone, like when you have a working directory up to date before we change. That's typical situation probably in local environment. You have like your project pre-built, previously you have changed, now you run tests, and in that situation you probably will hit, you will restore not touched modules very fast, and you will rebuild remaining invalidated modules. And in my benchmarks, that took like 54 seconds. So great improvement, again, like much better when like doing full build. But in continuous integration, you likely will start with clean directory, right? And in that situation, you will do a kind of mixed performance. First of all, you will need to restore cache, which actually will be somewhere between this and this, depending on like sizes of your tasks outputs. And also you will do rebuild of like 25% of your tree, because like we changed. And in my benchmark, that took 1 minute, 34 seconds. Again, like much better when we clean build, but you still see that like performance degradation is visible, and compared to other situations. On contrast, Maven in that situation scales just perfectly and completes in 57 seconds in both situations. And and one more important here to understand that this is a local cache, right? No remote calls. And if you have situation with remote cache, that means you need to add also price of transferring data over network. And because that could be quite extensive, for example, for Gradle, because it stores inputs and outputs for every task, even intermediate one. So basically, you can expect much higher impact of remote cache on Gradle compared to incremental Maven implementation, which only stores and restores final results and doesn't restore intermediate state. So basically, in many situations, you can expect much better numbers, much better resources utilization for incremental Maven. And because of that, it could be absolutely fantastic. It could show absolutely fantastic results for your continuous integration. It could maybe unclock it efficiently and save you, I don't know, AWS bill and from unnecessary expenses. It's great. It works. You can use it. So please give it a chance. Try it. I'm sure you will like it, and it will be helpful to you. So that's it for today. I hope I will have a chance to share more useful information about incremental Maven. But at this point, it's all for today. Again, thanks for Deutsche Bank for contributing to that. Thanks for my colleague who helped to implement this, and many thanks to Apache Maven community for supporting our small project. Thank you, and hopefully see you again. Bye.